Hey guys, if you're watching this, that means I'm at the Philippines enjoying my vacation. Sorry to rub that in, but anyways, I put in some time before I go to get you moving along, so um, let's do that. So I got my little guy. Here he is. I thought he was going to take a nap, but he doesn't want to go down. So I'm sure during this video at some point I'm going to have to pause it, put the little guy down, and then I'll continue. Okay, guys, make sure that you have this worksheet out in front of you. Hopefully it's completed. If not, get one from, if you don't have one, get one from the sub and follow along. But we're going to just work together through this. Make sure that you pick up the big ideas of what I intended through this worksheet here. Okay, so the first one, let's take a look at is this construction of quadrilaterals 1 and 2, because hopefully when you answer the questions and you looked at these central angles, when all the central angles were the same, we made a different special quad. So let's look at the construction there. It says to construct a circle, and then we're going to just do two diameters. So let's get the circle tool out. You can either follow along with me right now if you want to, and this Mr. Sub, if you can pause it whenever the kids need you to, so they can get caught up or whatever, and then play it, as a group, that'd be great. Just make sure everybody follows along. You don't have to follow along. You can just watch if you want to. This video is in your quest that pops up on Thursday or Wednesday. But anyways, let's move along here. So I'm going to grab my circle tool here. It says create a circle. And then it says create two diameters. So we have to get a segment that goes from, say, a point on the circle through the center and opposite. Okay, so I'll show you two ways. I'll show you the way that you did it in the worksheet, and I'll show you what's called the reflection of a point tool. So one way we could do this is you have to use your line tool, because in a line, I need 2 points, like the point on the circle in the center, but the segment would just be the radius, right? But I want the line because I want that intersection point right there. So now I'm just going to grab my segment tool, put the endpoint right at that intersection, and the point on B. So now I have a diameter. I could even get rid of my line here. So there's one. Now another way we could do that too is I'm just going to put another point on the circle here. And then I'm going to use in my transformation toolbox, there's the reflect about a point. So what reflect about a point, like we talked about on Monday, I believe. I'm making this before Monday. I hope we talk about it on Monday. But if you use the reflect about point tool, what it does, I'm going to click on D, and then I'm going to click on A, and it just reflects that point through A. So it just makes the same distance on the opposite side of A there. So we just reflected D over A. So that creates that point we needed too. So anyways, we got two diameters. Now our quadrilateral is this guy. So the main question here is, what kind of special quad do you think you constructed and why? I would say it looks like a rectangle. Sorry. Looks like a rectangle here. And why? Let's take a look at these angles right here. Ooh, 90 degrees, right? To be a rectangle, we have to have this 90-degree relationship. So all the interior angles are the same here. They're all 90 degrees. So that would be a rectangle in my opinion. It's a quadrilateral with 4 90-degree angles, right? So I think we constructed a rectangle, and that is why. It's got 4 90-degree angles. Okay. Measure the 4 interior angles of, well, we just did that. Let's go to the 4 central angles. So if we measure the 4 central angles, and then I said color the congruent angles the same. So these two angles right here, because they're vertical, are going to be the same. And these two angles over here, went the wrong direction. And then these two vertical angles are going to be the same. But the main thing here is that the vertical angles, the angles aren't all congruent, right? So in a rectangle, your diagonals won't be perpendicular, but if you do try to make them perpendicular, then we get what looks really close to, say that's pretty close. Now if you look at it and say they were actually perpendicular, that would be a square, and all the angles in here are perpendicular. All these triangles are the same, are congruent. In a rectangle, all four triangles aren't the same, but the triangles opposite of each other are. Okay, so measure the four central angles. Okay, so if the central angles are not all congruent, we made a rectangle. And if the central angles were all congruent, all 90 degrees, we made a square. Okay? Okay, so you should take a screenshot of either your rectangle or your square, whatever special quad you got going on. But there's our first screenshot. So let's make the third quadrilateral here. So your first two were the rectangle and the square. Quadrilateral number 3, new window. We're just going to do a line segment. We're going to make an angle basically with segments here. And then we're going to use our parallel line tool. So let's do that. So segment, segment, and then in our construction toolbox, we'll get the parallel line tool, parallel to AC that goes through B, and then parallel to AB that goes through C. And then that little intersection point is our fourth point there. So there's our special quad number 3. And as we move the points around, ooh, we can make a rectangle. We can make a square, I bet. Right, something that looks like a square. So we can make a square probably. Okay, but not always, right? Okay, so this is a parallelogram, right? And we made it actually by the definition. It's a quadrilateral with opposite sides parallel. Okay, so we need some segments for the two sides that are made up of the line right now, because GeoGebra doesn't identify a segment yet until we make one. So now we have the 4 segments, and we can hide our lines now. So here is a parallelogram construction. Okay, so let's see. First question here. What special quad is constructed? Parallelogram. Why? Opposite sides are parallel. Okay, so let's measure the 4 interior angles and see what's going on there. So those are obviously not congruent. I hope that my son's not as loud as I'm hoping. Okay, so if you look at the angles here, you can see that we have angles that are what we call across from each other or opposite from each other. They're congruent to each other, right? So no matter what our angles look like, we're going to have that relationship. Okay, so in a parallelogram, what do we notice about the interior angles? We notice that the opposite angles are going to always be congruent to each other. And we'll reason that why that's always going to happen. Okay, but that's just an observation to make. So as you move your parallelogram around, just see that that's always going to be true. Okay, so what do you notice about the interior angles? The opposite angles are always congruent to each other. Okay, now let's use the line segment tool to place a segment. Okay, we just did that. What do you notice about the lengths of the sides? So let's grab our measurement tool. It's in our angle toolbox, distance or length tool. We're just going to click on these segments. And we can get the distances up. So on mine, these opposite sides are congruent to each other, right? And they look like they are. So in a rectangle, we know opposite sides are congruent. In a square, all 4 sides are congruent. Ooh, I almost had it. Dang it. But in a square, all the sides are congruent. Okay, in a parallelogram, opposite sides are still going to be congruent, just like in a rectangle. So that's a nice property to know about parallelograms. Opposite sides are going to be congruent in length. Okay, so take a screenshot of that. And then our fourth quadrilateral is going to be a kite that we're going to make here. So we're going to make an isosceles triangle. So you might want to pause it. Okay, isosceles triangle. So we're going to just do the circle construction with 2 radii. Okay, so I'm just going to make a circle, and then I'm going to grab my segment tool and make 2 radii. There is my isosceles triangle. And now I'm going to take my perpendicular bisector tool in my construction toolbox, and I'm just going to click on the base of this isosceles triangle, goes through our center point. So to finish our kite off, all we need to do is put a point on the perpendicular bisector, because any point on the perpendicular bisector of a segment is always going to be equal distant from its endpoints, right? So those lengths are guaranteed to be the same length. Okay, so I could even move D around, and we can get different looking kites. I can move, this center, make it. So this is a kite construction. Okay, and we can see all sorts of different kites. Okay, so what special quad you make? You made a kite because there are 2 pair of congruent sides, adjacent congruent sides, right? So these are congruent and these are congruent. Okay. What do you notice about the diagonal relationship? Okay, so if we look at the diagonals, we've got this right here and this segment that's really on the line right now, but that diagonal, this diagonal, they look perpendicular no matter what we do. So we can measure that, right? So I'm going to just put a point right on the intersection and got my angle tool, and let's just check. Yep, 90 degrees. So the diagonals are perpendicular to each other, no matter what our kite looks like. Okay, so measure the 4 interior angles, all right? So let's do that. So, boom. Okay, there's all 4 of my angles, and if I look at all 4 angles there, I can see, what am I doing? I can see that these 2 angles right here are congruent to each other, and really it kind of makes sense, doesn't it? Because this lower triangle right here looks just like this upper one, right? Kind of like a line of symmetry, line of reflection. So you could reflect one triangle onto the other. So that angle would just reflect onto that angle, right? So if you look to the diagonals, since we're talking reflection, right? Like I could put a triangle right here, and then I can grab my reflect tool, reflect about line, so reflect this polygon over that side, right? So we have a reflection going on. So this angle right here and this angle right here would have to be the same because they would just reflect onto each other. And same deal down here. That little angle and that little angle would be the same. Therefore, this diagonal cuts these angles exactly in half, right? It bisects the angle because of that reflection property. So we have some nice congruence and symmetry in the interior angles. So make sure you write that down. There's a pair of congruent angles, and the other 2 get bisected. Okay, so submit that or grab that screenshot. Last one, construction of a special quadrilateral number 5. So let's do another isosceles triangle. We're going to reflect the center point over the base. Okay, let's see what that means. So, make a quick isosceles triangle. There we go. So this would be the base right here, right? The base is really the chord of the circle. A chord is just a segment whose endpoints are on the circle. So we just need the perpendicular bisector. Oh, no, we don't. We're just going to reflect that center point, right? So I'm going to grab my reflect tool. I'm going to click on the center point and then my base. There's my reflection point. All right, so what did we make here? So let's see. Looks like, looks like we can make a square. So we can make a rectangle maybe. Oh, I don't know. Doesn't seem like those side lengths are getting any different. They seem like they're all the same. We could check that too. I'm going to grab my distance tool and check the lengths, and oh hey, all the sides are the same. So we made a rhombus. This is a rhombus construction. So no matter what, we always have a rhombus here. All the side lengths are congruent. We check the diagonals out. So if you measured those central angles right here, you would find that the diagonals are always perpendicular to each other also in a rhombus, just like in a kite. Kind of looks like a kite here, except these two sides that are equal in length to these two sides that are equal, right? Because all four sides are equal. And that's not a kite definition, that's a rhombus definition. So that's why kites have to have different values in our congruent segments. But we have a nice rhombus tool here. Okay, so answer those questions. Oh, what did we notice about the interior angles? Didn't measure those. And it looks like to me that in a rhombus, oh man, opposite angles look like they're congruent to each other. So no matter what our rhombus looks like, our angles that are opposite are always going to be congruent. And if you look at symmetry, looks like these four triangles inside are also all congruent to each other. So we would have congruent angles going on in here, right? We could just rotate, and we'll play around with that too as we investigate these special quads a little further. Okay, so get a screenshot of that, and you are done with that assignment. Make sure that in the quest you submit all your 5 of your screenshots. Really, I guess there would be 4 screenshots, right? Because your first one you're making either a rectangle or a square, but take a screenshot of one of them. So really, there should just be 4 screenshots, okay, in your 3D game lab. All right, guys, hope that made sense. Sorry to bore you, but make sure you understand that concept, get that quest done so that you can understand the next quests coming up. All right, take care, guys. I'll check in with you later.